Hey guys, so I am here to show you that even though we are talking about something new, it can be transformed back the old way. So if you're somebody that does not like change, this might be what you'd want to learn and know how to do. However, I am promising you that the new way, if you are presented a function or a quadratic equation in this format right here, it's going to be faster, easier, and less steps. But you are going to have to remember some things about it to be able to use it effectively. However, if you're like, new things are not my friend and you just want to spend a little bit more time with the old stuff, I wanted to show you how you can make our new kind of equation that's going to look like this now look like our old kind of equations. Now, the new way still has a square in it as the highest power. And that is important to make sure that it's still a square because that's what makes something a quadratic equation or function. So this square being the highest exponent that I see here is what's allowing me to say, well, this is still going to look like a parabola. You are allowed to jockey anything around, move anything, multiply anything, add anything, do all the operations to any equation in the world. It's called rewriting. And all you're doing is kind of like changing its clothes. You're making it look differently, but you're not changing the value of the equation that was presented to you at the beginning. So as long as you properly follow order of operations when you're simplifying, and that you follow all protocol whenever you are solving and manipulating equations, you're allowed to do whatever you want, okay? Now, here's how we can make this equation, which is a newer version of what we're used to seeing with squares, look like the older version. We're going to follow PEMDAS to simplify, just to make this look simpler and in a different format. Parentheses in PEMDAS means that we are looking inside of the parentheses and we're seeing if we can combine anything inside of there. And certainly we cannot take x and a minus 3 and combine them because they are not like terms. So the parentheses step in this problem is totally useless. The next step is exponents. An exponent are these little numbers up here, and we certainly have one here. Remember that what an exponent does is it multiplies the base or whatever is being raised to that power however many times or however many times this power is. So because there's a 2 here and the 2 is attached to this group of terms, I would be multiplying that by itself twice. If that was hard for you to determine, remember, like if you're doing 4 squared, this really just means 4 times 4. Or if you're doing x squared, it really means x times x. Well, x minus 3 with a square on it just means x minus 3 times x minus 3. Now, you cannot forget about all the other things that are in this equation with it. We have this y, we have a 2, and we have a plus 5. So here is what the exponent step would look like. Now, the next step is multiplication or division from left to right. Thankfully, I don't have any division in this problem, but I do have heaps of multiplication. I've got multiplication here between the 2 and this, and then I have multiplication here between this and this. So what you'll do is you work left to right. You do the first multiplication first. So I will take these two things, and I'm going to multiply those together first. The 2 distributes into here, and you get 2x minus 6. Now, all of this here has to multiply with the x minus 3 now. And I'm dropping everything else down for the next step. So the y equals comes down, this plus 5 came down. All I did was distribute the 2 through here. Notice that the 2 does not go all the way back here. It's when the parentheses stops, that's when the distributing stops. Now I see that there's more multiplication, so I'm going to do this next. I'm still in the multiplication and division step here, and I'm going to have to distribute here as well. 2x times x gives me, I'm going to write that y equals 2x squared. A 2x all the way back here times a negative 3 is a negative 6x. Then I'm going to take the negative 6 and multiply it through. This is something that's very familiar to you. And a negative 6 times a negative 3, which makes a positive 18. Bring down that plus 5 I've done nothing with. And now I see that there's no more multiplication or division that I can actually do. Technically, there are multiplications like 6 times x, but I can't actually multiply them together. I can just put them up together. I can't multiply a variable and a number and get something different than just that. The last step then is to be able to add anything that I'm allowed to add. And so I'm allowed to add like terms. I do not have any other x squared, so that's my only x squared. Here are my x's. These are called linear terms, so I can combine those and get a 12x, a minus 12x. And these are my constant terms, or just the numbers, and I can add those together and get 23. And this is now the old way, where I have an A and a B and a C, and I can use all of the things that help me graph in this format here. So I would have to start with the vertex. To find the vertex, we use the negative b over 2a formula. So negative, and then my b is negative 12 all over 2 times my a. This is all old news. Your x value of your vertex is going to be 3. We plug it in then. I got to move this thing. We plug it in then to my equation to see what the y is that's paired with it. 2 times 3 squared minus 12 times 3 plus 23. This, when I put it in my calculator, all comes out to be the number 5. So my vertex then is at 3 and 5, and there's my first ordered pair. Then you'd have to find your solutions or your zeros, and to find your zeros, the best bet is to use the quadratic formula. This is all old news, right? We use the quadratic formula to find those two values. So x equals my negative b, all plus or minus the square root of b squared, minus 4 times my a times my c. I'm going to fit it in there. All divided by 2 times a. Again, all these things you know, 12 plus or minus. Boy, if I do not know that, I really don't. Minus 4 times 2 times 23. That gives me negative 40. Oh, shoot. All over 4. And then I notice I can't even graph this because these are imaginaries. So this did not help me at all to be able to get my solutions because imaginaries mean I can't even graph them on the coordinate plane. So anyways, there's no point in going further with this. The third thing then is to just pick some points and plug them in. Pick something close to our vertex x. So I would maybe pick 2, and I'd plug in 2. And then maybe I'd plug in also 1. Whoops, I plugged in a 3 there. I'd also plug in 1 and see what I end up getting from these two things. So this is all old news, but man, that was a lot of work. Even when it was presented to us this way, starting with the purple, it took us a long time to get the graph. What if I told you, though, that none of this work here in the simplification step is needed, and none of this technically if I'm given the new way of graphing, or the new way of showing a quadratic function? What if I told you that none of this needs to happen? Now, again, you can't just forget all of this stuff, because if you're presented with this kind of equation, you have to go through it this way until I show you another way. But anyways, for right now, if you're given something in standard form, you have to go through this step procedure. If I give you something in what we call vertex form, there are some shortcuts. But still, with anything new, you're going to have to learn it. So please make sure that you are paying attention and discovering how we can use this vertex form possibly, so that tomorrow when you do your assignment, this goes pretty smoothly.